So welcome to this session. My name is Claire Barlow. I'm a lecturer in the engineering department. I'm interested in sustainability. I'm from the manufacturing side, so I'm concerned with some of the bad people who make lots of carbon emissions. Whereas Shaun is on the side of the angels, and he's now going to introduce himself.
So hello, I'm Shaun Fitzgerald. I'm with the Centre for Climate Repair, which is part of Cambridge Zero at the University of Cambridge.
Good. Shaun, over to you.
So in terms of just introducing the Centre for Climate Repair and the topic of climate repair, we are a new centre at the University of Cambridge, formed under the auspices of Cambridge Zero. Cambridge Zero was launched last year as well, and one of its key themes is carbon drawdown and climate repair. So this new centre is really being targeted at helping fulfil the research agenda and engagement agenda on that particular topic. And the Centre for Climate Repair has got three primary objectives. One is deep and rapid reduction of carbon emissions. The second one is greenhouse gas removal, which is going to be the topic that we discuss today. And the third one is looking at targeted interventions to try and restore particularly damaged climate zones, which are, for example, the polar regions. The reason why we have these three objectives is that when I started life as an engineer almost 30 years ago, I was dead set and very keen on sorting out the climate even then and addressing deep and rapid carbon emissions. So spending time looking at either green energy supply or making things more energy efficient, using less energy in the first place. But unfortunately, things have got away from us. And even if we were to stop emissions right now, we still wouldn't achieve the 1.5 degrees C target for global warming as set out in the 2015 Paris Agreement. Unfortunately, we need to basically drain some of the carbon dioxide from the atmosphere that we've been pumping up in large scale really since the Industrial Revolution. So that really brings us to the topic of greenhouse gas removal. And that's the reason why we need to think very earnestly about the kinds of technologies and how we actually go and use this as a way of restoring the climate, repairing the climate.
Okay. I mean, there are huge amounts of greenhouse gases being emitted, and how is it that anything that we can do is going to make enough difference that it's worth all of this scientific endeavour, technological development? Is this really going to make a difference?
It's a very, very good question. And when you say greenhouse gases being emitted, Claire, I think really it's quite helpful to think about whether it's humankind that's doing this, anthropogenic, or whether it's actually natural. So on the screen here is a figure that's taken from the IPCC report. And it's quite helpful in terms of just getting a sense of the relative scale of where carbon is and the fluxes of carbon dioxide in the world. So the blue numbers are really looking at the amount of carbon dioxide and the fluxes of carbon dioxide, which have got nothing to do with human intervention. So pre-industrial revolution times. And what you'll see that there's, I don't know, 150,000 gigatons of carbon dioxide stored in the oceans. There's a natural flux between the ocean and the atmosphere of about 300 gigatons of carbon dioxide each year. And then on land, the land has got rather less storage capacity. This is excluding rocks. This is looking at the living vegetation, living matter on land is about the same level of carbon dioxide as in the atmosphere, 2,000 gigatons of carbon dioxide. But when you add in soil and permafrost and things like that, you get to a number that's more like 15,000. But the fluxes from the land are 400 gigatons of carbon dioxide each year. So your question, Claire, which is what's the relevance of what we're doing? That's what the purple numbers show. And really what it's saying is that we are contributing about 40 gigatons of carbon dioxide to the atmosphere every year, 34 of which come from, frankly, burning fossil fuels, and And the rest comes from actually our activities such as deforestation and a bit of our agriculture and things like this. So that's 40 that goes up. Nature's a bit kind in that we get 20 back, because if you increase the carbon dioxide concentrations in the atmosphere, the way I like to think of it is in terms of partial pressures, it pushes stuff down, therefore you get a bit of payback on the ocean. So there's a net of 20. But in order to solve this problem and to start taking some of this carbon dioxide out of the atmosphere, we're going to have to live with this. So we need to zero this out. But it's really important, Claire, because it's a very non-linear process in terms of the way that the planet behaves. And therefore small fluxes, I'm going to call 40 gigatons as small compared with the natural things, is still a huge number. But actually, if we can make very significant perturbations to that, it will allow things like restoration of the polar regions. We won't then have the sea level rise, and the consequences of sea level rise are huge when it comes to the impact on mankind. Low level countries, certainly cities, being really badly affected, and getting to grips with this. So we can intervene by looking at this 40 gigatons number, and then actually taking some of that 900 gigatons, which is really the amount that we've now pumped into the atmosphere since the Industrial Revolution, that we need to take back into these storage areas.
So I mean, it's clearly hugely important that we should do this, but we don't hear very much about this. I mean, if you fly, you can salve your conscience a bit by buying carbon credits and what are presumably trees. And we hear a bit about carbon capture and storage for these filthy power stations. But what are all the other things that we can be doing, and how close are they to being technologically viable?
So there are a number of options that we have at our disposal for greenhouse gas removal. This little figure here is the cartoon. This gives you a sort of a flavour for the kinds of things that we can try and deploy. Some of them are at a more advanced stage in terms of technology readiness than others. So this is really sort of indicating that there are some natural processes. So the ones in green, for example, using plants as a source, whether it's forests, and then actually where that carbon goes, we're going to come on to that, but it's extremely important. So taking carbon dioxide out through living matter is the first step, and then what you do with it after that is a really significant question that we need to pose. And all of these have consequences on local environments, biodiversity, the people involved, and in terms of equity as well. So all of that's just natural processes. And then there are more engineering type approaches where we can look at using some of the science and engineering techniques. So let me just dwell a little bit on the kinds of options that we may have at our disposal, Claire. And I'll start with probably one that's extremely familiar. You mentioned the carbon credits that we can go and sort of buy to try and offset the fact when we fly to Australia. You know, how many trees do I need to plant in order to make sure that I've, quote, offset? It's an interesting question. It might make you feel good to do so. But the big question is, you know, using trees, there are a number of factors at play. The most important one actually is how scalable is it? So those few people who fly today, in terms of on a global basis, we can go and buy these credits, Claire. But if we go and scale up forestation or afforestation, so afforestation, I like to think of that is where you're intentionally planting trees, and reforestation is clearly where we've stripped the land bare and we're going to go and replant. How scalable it is, and it's extremely challenging to get to a situation because trees themselves, once they've, after about anywhere between 20 and 100 years, depending on what you plant, well, they then no longer take up much more carbon dioxide. So you need to figure out what you're then going to do with it. So it's a nice, I would say, relatively short-term measure, but is it the global panacea? Is it the solution that we need? And one thing that you can do is think about, well, let's take some of these trees down and put it in our buildings. So that's got sort of timescales of certainty. That we might think about the built environment being around for the next 100 years, say, Claire, but it's not as permanent as some of the other solutions. One can also think about using some of this material and burning it in a power station. And if you burn it and then what's emitted are concentrated gases of carbon dioxide, and you capture that through chemical processes, you can then try and dispose of that, for example, by putting it underground in a geological reservoir. And this is a way of therefore producing energy at the same time as effectively removing carbon dioxide from the environment. So that's that's a different way than, for example, burning gas or oil in a power station and then saying, right, I'm going to go and put that back in, because that doesn't help greenhouse gas removal in terms of negative emissions. It just helps get you to zero emissions. This particular process is helping us get to negative emissions, where we're trying to repair the climate.
Could I just say that there are some questions coming up, and some of them you're actually answering as you're talking. So without giving offence to the people who've put these excellent questions, I'm going to dismiss them. It's not that you've said something silly, it's just that I think that we're answering them as we go along. Okay?
Okay, and Claire, that was the sort of the first idea about using forests as a way of doing greenhouse gas removal. There are others. Wetland, peatland, habitat restoration. There's actually a reasonable potential here. And these numbers, by the way, in the top left that I'm quoting, there are two things to note. Is that the most important is that there's quite a big range. So it's still uncertain. There's a lot of research that needs to be done to really triangulate what is the potential, and then how does one go about availing oneself of that potential. But there are other benefits for things like wetland and peatland restoration, especially if you think about sea level rise. What do we do about flood defences and things like this? So actually using our coastlands as a way of actually A, trapping carbon, but B, at the same time trying to make ourselves more resilient against sea level rise and increased severe weather conditions. This is actually sort of an interesting approach to greenhouse gas removal. It's not a technology, it's a natural approach which has got potential benefits. Clearly, local communities involved. There are other issues as well as to, are we looking at doing this in areas that have now had the built environment imposed upon it? So, for example, looking at large ports that have been constructed in what was previously a wetland, peatland area. Do we now need to go and think about where else we might do this? So there are big factors at play, Claire, in terms of just the social aspects as to some of these technologies. And then another natural one is looking at increasing the amount of carbon that we can actually just store in the soil. As I mentioned at the beginning, soils and permafrost store about 5 times more carbon than the atmosphere itself, but actually it can do even more. We can actually store even more carbon in the soil. And that means just sort of changing some of our farming practices. Interestingly, though, some of these benefits could be that it could actually reduce the cost, increase the fertility of the land, but just using things in a different way. And then a final one of the more natural process is to partially burn things and create charcoal and then spread the charcoal on the land. And again, that can help with things such as increasing the fertility of soil, actually, and how resilient it is to water, but actually the productivity of soil can benefit from some of these things. And every time we're flagging up these numbers, Claire, the number I like to think of is 40 as gigatons per year, is the amount that we are responsible for, only 34 with fossil fuels. Each of these numbers together is adding up to be something that's of reasonable interest. So far, we haven't found one technology that's a silver bullet, but we are finding ones that frankly are north of 1 gigaton. Starts to get very interesting in terms of it being used as part of a portfolio of approaches. And then the last one in terms of the land for processes is there's this thing called enhanced terrestrial weathering, which is where looking at grinding of silicate rocks and things like this and spreading those on the ground. And silicate rocks, if you spread them on the ground, then over, and this is the big question about the timescales, reacting with the carbon dioxide in the air to create carbonate rocks. So we're looking at alkali rocks that we might grind up, but there are issues here regarding the resources that are needed. For example, where are you going to get the silicate rocks from, the mining that might need to be undertaken with this, the energy use, and then of course sometimes some of the processing of that, so that you don't then for example, have heavy metals being spread on the ground, do you need to do some cleanup of the rocks in the first place before you then put them on the ground and make them sort of as part of your soil management processes? I thought I might just touch on some other techniques though, Claire, that are sort of not just the natural ones. So mineral carbonation is really just looking at the overall concept of where you've got rocks that can be used. I mean, I'm thinking mainly silicate kind of rocks that can be used as natural traps for carbon dioxide. And if they can be ground and processed in outside of the ground, as a process, and you can have that those rocks in touch with carbon dioxide in a relatively concentrated form, then you can actually accelerate the rate or increase the rate at which this formation of carbonate material can occur. So that's what we call an ex situ process. And of course, there are just natural rocks underground that you might be able to put this higher concentration carbon dioxide, for example, injected into underground reservoirs. This is different from geological formations in terms of just old oil and gas reservoirs in the first instance. There might be particular reservoirs where you know that they've got rock formations that will then readily react with concentrated carbon dioxide to form carbonates. Now, the interesting thing about that is that if you can form carbonates, then in terms of just how permanent that storage now of carbon dioxide is actually quite high. Sort of a high degree of confidence that it's going to be locked in there for a long time. Whereas when I mentioned bioenergy carbon capture storage and putting that into a geological formation, one of the challenges that we have with that, I'm not saying it's a big challenge, but it's something we need to address, is the monitoring and verification that actually that reservoir then will store the carbon dioxide for thousands of years. It's still in a form that is not reacted necessarily with to become a carbonate. So there's just different sort of ways of thinking about the problem. And clearly, if we've got an abundance of old oil and gas reservoirs, which we're now going to use for good purposes as far as the climate is concerned, to go and then actually, because of the scale of the resource, maybe the effort that we need to put for verification and monitoring is absolutely worth it. And there's one other sort of approach that I wanted to introduce, Claire, which is the and more of an engineering kind of approach. And I don't know, people may have heard of this being mentioned in recent months. There was an announcement by Dominic Cummings, who'd said, oh, you know, he's going to put £100 million of government money into direct air capture and carbon storage. At first glance, I guess 100 million sounds a lot of money, but given the amount of money that it's being invested in other purposes for the last 6 months with coronavirus, I think it's, you know, it almost now looks like small change compared with some of that. But nevertheless, this is a big sum of money. And fortunately, I think the discussion has been broadened. So it's not just 100 million into this particular technology. It's 100 million into exploring greenhouse gas removal approaches more widely. But nevertheless, let's talk about direct air capture and carbon storage. This looks at basically getting carbon dioxide just from the air by blowing air across surfaces that have got chemicals in those that will then absorb the carbon dioxide, and then when you heat those chemicals, those surfaces, it will then release the carbon dioxide in a relatively concentrated form, and therefore becomes an easier gas to then be able to deal with in either, for example, taking that into a geological formation, putting it, thinking about mineral carbonation that we've just talked about, or creating products such as low carbon concrete. So using it in our building materials in a new way. So that's really the land-based. And then, as I mentioned at the very beginning, Claire, regarding the fluxes, one of the big stores we've got in terms of just the relative magnitude of where could we store carbon, the oceans are just absolutely huge. So the amount of carbon stored in the ocean, as per that initial slide, I don't know, 150,000 gigatons of carbon dioxide compared with 15,000 on the land. These have got huge potential. And there are certain areas of the world where the ocean is not as fertile in terms of the amount of living material, living matter there, as perhaps there could be. And it's because they're missing, the ocean is missing some particular minerals, which if they were provided, you could then get sort of growth of phytoplankton and things like this. So for example, iron, if that was deposited on the surface of the ocean, that can sometimes trigger huge growth of phytoplankton and other living materials. And this has been observed in nature. So when you have major dust storms from the likes of the Sahara, and that blows over the ocean, you know, a few days later, then there've been observations with just huge amounts of natural growth in the oceans, which are as a result of now the oceans having available, whether it's iron, whether and there are other chemicals that we could use potentially for nitrate and phosphorus. There are big issues though associated with this. We don't know how permanent the carbon sequestration, which is as a result of the carbon dioxide being taken up by living matter, how permanent it really is. Unless it goes to the deep ocean, is it just a relatively short time scale where it then just gets recirculated and back out to the atmosphere? So there are experiments that are needed. There are big questions regarding the intentional triggering of increased biodiversity, increased living systems within the ocean. We're extremely nervous about trying to perturb the natural environment, and it's whether it's for good or for bad. We just got to be extremely careful about perturbing the natural environment. That said, Claire, we don't seem to have been too concerned about perturbing the natural environment over the last several hundred years by just burning loads of fossil fuels, and now we know it's bad and we're more than perturbing the natural environment. So we need to make sure that we take a balanced view, but ultimately it's the people that will decide and not the scientists as to sort of what is right and what's wrong. And then there are certain areas of the world where the oceans have been acidified. And we've got bleaching of reefs and things like this. So there are actually some specific things that one might do by increasing the alkalinity, or rather reducing the acidity of the oceans, and then having that as a way of triggering increased uptake of carbon dioxide into the oceans. So this table here, Claire, it's taken from a report that was issued a couple of years ago by the Royal Society and the Royal Academy of Engineering together. And it gives you a sense of the relative magnitude of the storage potential. And as I said, I think the number that I just work with is, I've got this 40 gigatons per year that I certainly need to zero out. And then that other number, which is pretty scary, which was the 900 gigatons per year, 900 gigatons of carbon that's now in the atmosphere that wasn't around before the Industrial Revolution. If we want to bring and repair the climate and restore it to what it was to pre-industrial levels, we're looking at something like certainly 700, 800 gigatons of carbon that we need to try and remove. So it's hundreds of gigatons of carbon dioxide that we need to try and remove from the atmosphere, on top of turning the taps off in terms of stop emitting the stuff in the first place. I mean, we must say, I think of it like a bathtub, Claire, which is full of dirty water. What do? Well, the first thing is that you need to turn the taps off to stop the dirt coming in, and then you need to drain the bathtub. And there's no point in draining it, continuing to keep filling it in. I mean, it's just like, it's nonsense. So all of this discussion about greenhouse gas removal, it's important though it is, I can't understate the importance of turning the taps off.
Okay.
Anyway, those are our options as we see them at the moment.
Yes. So most of the attention is focused on turning the taps off, and that's clearly hugely important. We're not doing nearly enough of that. We need to keep up the pressure. But the greenhouse gas removal, I mean, as you've talked through them, some of them sound technologically very sort of heavyweight, as if they're going to consume huge amounts of energy and resource to make this removal process possible. So I'm sure that people have done the balancing there and reckon that it's still going to be overall beneficial. And then you've got the oceans, which are tremendously exciting, but really very scary. A whole new ecosystem that we absolutely don't understand, that we're trying to meddle with. And it's a really global phenomenon, isn't it? This isn't just, one country that's dealing with this. This is, going to affect the whole world. So how does that play out?
So you raised a few things. So in terms of the resources required and the impact on society and an impact on people is absolutely enormous. So firstly, the energy that's required for some of these processes, that does need to be factored into it, into sort of figuring out what the right portfolio is. If that energy can be provided by fossil fuel free means, so for example, wind power and things like this, then okay, well, I don't like building loads and loads of wind turbines just to go and do greenhouse gas removal if there are other better or easier approaches to use. Nevertheless, the energy argument is something that is something that we could potentially address through just deployment of technology. There are other factors, though, Claire, which I think are arguably even more important. So, for example, if we're going to start looking at the use of land for forestation and things like this, this has an impact in many, many ways. Has an impact clearly on whose land it is right now, in terms of what they're doing with that land. So on people, has potential conflicts with things like food production. What would this do for certainly price of food, but I would say on a social conscience point of view, availability of food for different parts of society. When I talk about society, I mean about the world. So we shouldn't be using these technologies and approaches to increase the disparity of wealth, for example. We should be looking at how do we use some of these big schemes, big ideas to try and reduce the gap and make society more equitable. And that's very, very important. And I think that resonates with a lot of people today, is that we know that society isn't quite as fair as it should be. But if we're going to be making massive investments, and we are talking hundreds of billions of pounds of investment that are going to be needed to do this at scale, then we should be thinking of it not just for the benefit of the climate, but for the benefit of humankind today, and therefore looking at social factors, which I think really, really important. And then we come on to the biodiversity issues, Claire. With the oceans, for example, the opportunity is enormous. The questions are absolutely gigantic, and therefore that means that it's worthy of experiments and more research. And that's what the Centre for Climate Repair is about. We're not here to try and push one approach versus another. What we are here to do is to try and sort of get to grips with what are the big questions that need answering in order to arrive at what is going to be the right portfolio of approaches to address this problem. And the questions that need answering are not just technological, they are societal. The social sciences, have just got, it's not that we ask about the social sciences after figuring out the technological ones. No, they need to be addressed all at the same time in harmony, so that we don't actually sort of bark up the wrong tree, excuse the pun, for the appropriate approach that we're going to be using.
And of course, time is a big factor. We need to be doing these things now. And some of these are technologies that are going to take decades to actually ramp up, even if they're viable at all. What can we do quickly?
Well, that's a very good question. I mean, some of the approaches are more advanced than others. So the first one on the screen right now, so the idea of forestation is something that we can get going with now. BECCS is something we can get going with now. That said, although it's at a more advanced stage, Claire, it doesn't mean to say that therefore that is the answer that we should be pursuing. In other words, it's important we get going. What's more important for me is that we need to have a balance of the stuff that we can be doing right now, but we've got to get to grips with research in the other areas which are less advanced, for example, that might actually provide bigger opportunities to actually really then solve the world's problems. So we need this balanced approach of doing what we can now, but by goodness me, investing in funding research, which has been quite, it's not at the scale as it should have been really over the last few decades. And that's, I think that's really, really important. That's the big missing factor that research is needed into many of these. You saw the range in the numbers that I was presenting. Well, that alone says, gosh, we need to sort of button these down. But I think the societal factors and things like this are just as important.
Yeah. Well, you make a very persuasive case. Who is listening to you? Are enough governments listening to you? Because we do need, global impetus to get this going, don't we?
So it's a very good question. I mean, there is a lot of talk at the moment about, which is the right thing, of turning the taps off. What is the transition for moving to a zero carbon energy mix, for example? So there are a lot of discussions going on about that. There are fewer discussions regarding addressing greenhouse gas removal, but I think we need to up the ante. I think we need to have more conversations about this and say, I think 100 million announced just this year for the UK to undertake research and do some reasonable scale experiments is a good starting point. All right, so 100 million starts to get interesting that the government's committing, but we need a lot more money behind that, so that we just don't leave it too late. Every year that goes on, it's another 40, isn't it? It's another 40 gigatons that we've now got to sort of remove from the atmosphere. So we need to sort of turn the taps off, and I've still got my 800, 900 gigatons that we now need to go and put back into some form of sequestration state.
Good. We've got lots of questions that have come up. And Shaun, I don't know if you would
I haven't had a chance to read them actually, so let me.
Well, we've got 40 live questions. So could you maybe just take a moment to scan down and pick a question that you think could be answered?
Okay, so let me have a quick.
It will be. What I suggest you do is just to read it out when you.
So, right, there's a lovely question. All right, in the recently released report of the Climate Assembly, which was, by the way, I think a fantastic initiative, getting a wide range of views on this, massively important, has made it clear that there is little public support for CCS, so carbon capture and storage, and much more for natural approaches. How do we resolve that? So that's really interesting. I think one needs to sort of peel the onion and understand why there is little public support for carbon capture storage. I think for me, the real issue is that I don't think there's any easy answer. All right, so I'm not saying that CCS is what we should be doing at all. I think it's a sort of we're at a too early stage in our deliberations and research. And what I'd be interested in is trying to understand, well, the answer being there's much more support for natural approaches. We understand that, right? That the natural environment and restoring that and using that as our potential to sequester carbon. How do we resolve this? Is by thinking about the world and thinking about the overall scale of the problem that we've got and the scale of the opportunity that just natural approaches might avail us of, and by appreciating frankly the difference, right, in the magnitude of if we just look at natural approaches, if we can't do it just with natural approaches, then we need to engage and invite the public, I actually would think, in terms of helping think through what the right alternatives are worthy of at least investigation. So we just can't. So if we can't do this, I wouldn't sort of say, right, well, let's go and tell them more about carbon capture and storage. No, I think where I think the Citizens Assembly is going, and this is that if you involve people in helping craft the decision, but with the facts laid bare to say, look, we need, it's that won't do it. It's not big enough. What else can we do? And just have all of the ideas on the table and involve people from the get-go, Claire. I think that's what's really involved. So the support for me is a consequence of how you've actually been able to engage in the first place.
One of the things that you've highlighted is the need for power generation, which is a global issue, but is particularly important for the developing world. How can we do the power generation in a zero carbon or negative carbon way?
So, well, certainly in the zero carbon way, Claire, there are technologies which are available now. I mean, things that we're familiar with, wind power, photovoltaics, and a whole raft of others which may or may not be appropriate for given geographies. So depending on what the natural resource is, if you're on a coastline, you might have different technologies that are going to be right for you, whereas if you're in the middle of a desert, it's probably going to be looking at wind and solar. Solar actually might be particularly attractive. So developing countries on that scale, that's for zero emissions, but for negative emissions, it may well be a case of, for those particular areas, do we look at things like BECCS, where they then get their energy and are able to contribute towards the negative emissions target, in other words, greenhouse gas removal, active to try and restore the carbon and basically rip it out of the atmosphere. Maybe that's technology which is appropriate there, but it might not be appropriate for certain other areas where actually there are better things to do because we've got land constraints. It might be a case of, no, we're not going to be doing this. We're going to be using different approaches because we've got a more densely populated country where land is scarce. We can't use forestry to go and use for carbon sequestration. So there may be other approaches depending on which country that we're talking about.
And for all of these, there must be a financial penalty as well, which is particularly severe when you're working with developing world. How does that work?
So the cost, all right. So the cost of a new world. I mean, Claire, I guess as a saying, there's no free lunch, all right. So I'm not suggesting that actually this is all easy. That said, I think there are different ways of sort of at least considering the issue. The first is, what if we don't do anything and we kick the can down the road? Then the costs associated with things like dealing with rising sea levels, well, the costs of that, sea defences and things like that, well, it starts to get actually sort of big money, rather interesting. It gets a very scary scenario though when you have countries that are no longer inhabitable, or certainly cities that are no longer inhabitable. And we've seen the migrant crisis into Europe from Africa. If we now start talking about countries that are no longer inhabitable, it'll make those migrants crossings seem like a tea party compared with the kind of migrations that we might be seeing. So, and what are the costs associated with that? Because actually we're a society altogether. So on the money side, that's sort of, I guess that's a more of a negative view. A more positive view is that there are co-benefits. So for example, on the ocean side, there are people out there who've been exploring what the co-benefits might be to enhance fish stocks. Not that the fish are the answer to the carbon sequestration, they're just, I think, a consequence of there being more phytoplankton and more stuff sinking to the bottom of the ocean. It then increases the productivity or the amount of sea life in the ocean. And actually, do you then start having increased industry with this sort of thing? And then, so there are potential benefits, Claire, for certain approaches where actually it's the right thing to do from an economic point of view. I'm not saying that that is the case in all instances, but there are some. And I think that the challenges that we have as a society are that, as I've been thinking quite a lot about this, is that the amount of money that we have had basically flying around by government in the pandemic to try and sort of keep people employed, for example, the scale of money that we've seen is something that I've not seen in my lifetime in terms of addressing an event. And if we were to use that kind of scale of money for this activity, it gets really, really interesting. And in fact, because we've increased all of this debt, so certainly one of the arguments I've heard is that how do you get out of this massive debt is that you borrow more. I know it sounds a bit odd, but you borrow more, but you invest it in infrastructure and invest it in things. So if we're very smart about how we invest more in our economy and develop some of these ideas, then actually maybe we're even weirdly, it might be an easier conversation to have now than it would have been even 12 months ago. Certainly the urgency is still here, and it's one more year of 40 gigatons, and we absolutely need to do it.
Do you want just to take a moment to flick down this ever-growing list of questions?
Yes. So, lovely question. Is anyone modelling the combined and/or possible synergistic effects of all these solutions being applied at the same time? So, this is really, really interesting. So, it's one of the things that working the Centre for Climate Repair, we're talking about greenhouse gas removal, but actually it's got ramifications in other parts of the carbon agenda, and therefore working with other academics through Cambridge Zero, who look after all basically the Cambridge Zero activities across the university, whether it's what we do with wind generation and wind farms and things like this. So what's really interesting is that when you start to build a suite of portfolios, in some cases you find that they're competing for the same resource. Well, that's whether it's people, whether it's land, whether it's energy, whether it's minerals. One needs to be extremely cognizant of the fact that you can't just add them all up. In other cases, Claire, there can actually be co-benefits. So, for example, depending on what you plant where, so planting the right things in the right places can actually lead to increases in productivity. So, breaking up, for example, certain land areas and having some set aside for trees and not just all of the same crop, you then get these co-rotation benefits on certain timescales, which then lead to increased productivity. So that modelling is the sort of stuff that we are working with at the Centre for Climate Repair and pulling together teams from across actually not just Cambridge, but from other academics in other universities as well. So we've got very strong links with UEA. That we're developing, UCL and Manchester, and we were looking to extend our relationships with other universities too. We've got particular expertise in certain areas, but this question of looking at the potential synergies, potential conflicts is massively important, and those are important when you think about also not just the technology side, but resources and people.
Mm-hmm. Yeah. What you're talking about on the agriculture side, those are hugely complex, interlinked systems, aren't they? And it's very difficult to do something without changing something else in ways that we absolutely don't understand. And so if we can get some benefits from that, then that's tremendous.
Yeah. So another question, which is short, to the point, and extremely pertinent, right? So couldn't ocean fertilization result in bad consequences, e.g. algal blooms? And the quick answer is absolutely, it could. But so that's the downside. But actually, there are huge opportunities for this. But it really, really is important that there is therefore research that's done in this area, frankly. And the first question I am worried about is, what are the downsides? What is the harm that, frankly, any of these technologies could potentially reveal, Claire? I think one needs to address the idea, how bad could this be? What could I do wrong first, right? Certainly as someone who cares about our planet massively, we've messed it up so far. I don't want to mess it up even further. So I want to know, first of all, look, what are the things that could go wrong? What are the experiments I need to do first, which will ensure that actually we're not going to mess it up? But I'm only going to pursue some of these things if I know they've got reasonable potential, Claire? But the first question, so I think it's a really important question, but that's why we need to do experiments to make sure that we don't sort of suggest things that could be detrimental to the planet.
But as you've said, trying to get some of these technologies into actual operation is going to require people all over the place to buy into them, to be happy with them, to be content. And getting people to agree to some of these hugely problematic technologies does sound to me to be quite a difficult task. I hope somebody's feeling jolly persuasive.
Well, certainly getting to grips with international cooperations. There's another question here. So could the, in brackets, post-Brexit, UK begin large-scale testing of carbon capture in its territorial waters, or does it require international agreement? So this is extremely important. So there is something called the London Protocol, which signed by international groups, countries, saying that you're not allowed to do dumping at sea. And I think we would all agree that sounds eminently sensible, and I would be the first to say that's exactly correct. We shouldn't allow dumping at sea. So if you want to undertake experiments at scale in the ocean, there are big questions as to, well, does that constitute dumping? Answer first is that I would say, assume it does. All right, let's go back to it's really similar to the previous question. The most important thing is we've got to make sure that we don't do any damage. So let's assume it does constitute dumping, and then engage in discussions, right, as to, right, well, what experiment would be needed in order to convince us that actually this particular process, this approach, isn't going to damage, right, the ecosystem, and in fact it might have rather big benefits to the ecosystem and to carbon sequestration. So getting permission is very, very, very important before you do an experiment. I mean, you know, the idea that you might want to just go and do an experiment without international agreement is just anathema. You know, getting the agreement across party is massively important. And if that means that we have to delay by 1, 2, 3 years, Claire, that's okay, because if you go and do things without the appropriate protocols in place, then even if you end up with the right answer, the damage you've done, certainly to science, by not following international agreements, means that you won't be able to pursue what is potentially sort of something that's a significant solution, part of the solution for the planet. So I couldn't agree more that that you need to have international agreement on these sorts of areas.
Does everybody have to agree?
Well, that's a good question. Does everybody have to agree on certain things? Whatever is set up, all right, you need to have make sure that the instruments, the political instruments that you've got, Claire, you need to play within, behave within the rules, all right, without a shadow of a doubt. Otherwise, you lose your credibility. Right. So I had a question, actually, although it's not related to greenhouse gas removal. I was asked about my views on nuclear power. So look, one of the objectives of the Centre for Climate Repair is deep and rapid reduction in emissions of carbon dioxide, as it is with Cambridge Zero. Fully on board. That's the alignment of this. It's really, really important. Where I am with nuclear power is that I would prefer us to not need nuclear power. Don't get me wrong. Because of the nuclear waste arising from this. Do I think we should do without nuclear power? Is a different question. Because I've got to turn the taps off, Claire, and therefore, what is and I've got to do it quickly. So, what's the right pathway for us to pursue regarding globally getting us to certainly zero carbon electricity, but zero carbon? There may well be a role for nuclear power, but I would like to think of it as, and I'm going to say in the near term. And when I say near term, clearly it could be multi-decadal, but as we see this, if it's a necessary ingredient as part of our transition to a zero carbon power base, then so be it. But so I'm open-minded as to whether we need it, but my preference would be I'd like us not to need it. But clearly, Claire, I would like us not to need greenhouse gas removal, right? But we are where we are, so we have to sort of face reality in that regard. Right, so someone's asked, and a few people have asked, what about other greenhouse gases, methane and nitrous oxides and things like this? So you're right, I have talked so far mainly about carbon dioxide, but there are clearly other greenhouse gases that are extremely important. And methane, its potency in terms of its insulating effect, what is it, 84 times more powerful as an insulating gas for greenhouse gas than carbon dioxide. Well, admittedly, the concentrations are lower, but we do need to get to grips with methane and things like nitrous oxides as well. Now, methane, interestingly, doesn't have quite the same residence time in the atmosphere as carbon dioxide. Carbon dioxide is a right pain because it hangs around for such a long time, and methane, sort of after a decade, it's got sort of much less effect. Whereas carbon dioxide is still having playing merry hell with our climate, Claire, after a very long time. So, but there are things that we should be doing to tackle methane, and therefore there are some processes that we're looking at within the university, which is actually how do you go and tackle some of these things? Do you, for example, convert it to carbon dioxide in some fashion and then deal with the carbon dioxide? But no, you've got to address the other greenhouse gases. And nitrous oxides from agriculture and things like this, which is where there's a wider discussion regarding if you're looking at changing agricultural processes to reduce carbon dioxide, or rather get carbon dioxide out of the atmosphere, Claire, you need to be very careful that you haven't then thrown the baby out with the bathwater and then increased nitrous oxide emissions, negating the benefits of the fact that you've just been able to rip out as much carbon dioxide from the atmosphere. So, the answer is that although I've talked about carbon dioxide as part of the greenhouse gas removal, one needs to be extremely cognizant of the fact that you do need to get to grips with the impact on other greenhouse gases and do our bit to try and address those, but certainly make sure you've got the balance correct regarding the impact of those on the climate system. Actually, so there's another lovely question, which is about what about the elephant in the room? Won't global population numbers have to come down to make decarbonisation stick? And I mean, I've read various things, Claire, about actually what the future population numbers are, and I've been a bit surprised. Is that I've seen, and maybe these are just pie in the sky forecasts, but I've seen some forecasts written by reasonably sensible people that towards the end of the century, where we're starting to see a reduction in population numbers globally. Whether I believe it or not, I don't know. But the basis of the work that we are doing in Cambridge is considering the fact that population numbers are still going up, Claire, but actually therefore we need to transition ourselves to a zero carbon energy base, and then looking at actually what we need to do to take carbon dioxide and other greenhouse gases out of the atmosphere, whilst also providing enough food and water for the world. Because I throw in water there as an example, but some of these greenhouse gas removal approaches do take water to process those, and if that then starts to impact on the availability of fresh water for local communities, you're going to run into some significant challenges because, as I said, it's a societal dimension on this, not just technological.
Indeed. Yeah.
Right, lovely question. Could you estimate the cost per tonne for each of the methods? So there are a range of numbers. So there are a range of numbers for the storage potential. There are an even bigger range of numbers on the costs, or of basically sequestered carbon for each of these. And some of these, not many of them, are down at the $10 a tonne, but most of them are $100, $500 a tonne kind of numbers that we're looking at. which then begs the question of, which I think you alluded to earlier, Claire, which is, look, what are the sort of economics and businesses that you might need to sort of think about? And the idea of there being a carbon price, it's been talked about a lot, but the idea of needing to have some instrument where you then are able to finance some of these, the investments for some of these approaches may well be needed as we move forward. But I think that's part of the research as well. In other words, it's what technology, what resources, what society needs, and then actually how do you finance this? What are the right financial instruments? And it's all woven together in terms of the research that is needed. So the work that we're doing at Cambridge involves people from land economy, people from the Judge Business School, thinking about what the right kind of structures that you might need in the finance world in order to get these sorts of ideas implemented in the medium term.
It's because sadly, on the whole, business is looking at trying to make money out of things, and there are no short-term financial gains for these, but it has to be done.
So in terms of short-term, I think it really depends on what we mean by short-term, Claire, and what therefore the timescales of relevance. And I mean, in a way, I think, much as though people are quite willing to describe markets as fickle, in a way, markets are quite good. In terms of, if you think about share prices and things like this, it's all about the expectations of the future of that company, which is what they're predicated on. And if we see things which are going to see diminutions in what is expected of companies, behaviors and things like this, then that will impact behaviors at the board level. So even, for example, even this week, we've seen announcements where people are looking at a change of strategy to move out of fossil fuels by, certainly not tomorrow, but by 2050, because we have a transition plan to implement. But these sorts of ideas are things where, that's not because they're just being kind. People make these decisions because it's the right business decision. So we're going to see more and more of that.
So it looks to me as if we're about to run out of time. I don't know whether it is down to me to close the session, but Shaun, you've given us a lot of insights here into the future. It's all pretty gloomy, but you seem to remain upbeat throughout, and there's certainly plenty of work to be done.
So I certainly don't mean to be gloomy at all. I think it's a massive opportunity, and my closing remarks would be to all of our alumni who are listening today. If anyone is interested in wanting to get involved in this kind of area at the university and supporting it in some fashion, certainly Emily Shuckborough from Cambridge Zero, the director of Cambridge Zero, and myself with the Centre for Climate Repair, we would be absolutely delighted to be able to hear from you and to talk with you as to how we might be able to collaborate.
And thank you all for these fantastic questions. I'm sorry we've been able to tackle so few of them, but there were some really great questions come through. So thank you all very much.